So in my lecture today, I want to focus on the topic of big data. And more specifically, I want to focus on the ways in which the digital revolution and new technologies for the analysis of data, including machine learning, are opening up new approaches to the analysis of qualitative. And today I'm particularly going to focus on textual data. And this is going to lead to my argument that we're beginning to see something of a blurring of the divide between qualitative and quantitative social science. And I'd like to say from the outset that what I'm trying to do this afternoon is to inspire you and spark your interest. I'm not going to give a lot of in-depth information about things. I want to encourage you to talk to other people, go to other sessions in the festival to find out more. So I'm hoping that in the question session at the end, we can have more of a discussion than a sort of question and answer session. So in the very first part of my talk, I want to give a brief history of the use of the term big data, but also to provide an overview of some of the ESRC investments in infrastructure for big data. And I think this gives me an important opportunity to outline our big data network that we've been establishing just over the last 3 years. And I'm always struck by the recency of this. It really is just over the last few years. I'm going to go on to outline some of the different types of textual qualitative data that are increasingly available to us as social scientists. And in particular, I want to inspire you to think about new analytic technologies and analytic methods. And I'll finish by thinking about some of the challenges and responsibilities for us as social scientists when we engage with these new approaches to analysis. So my key message this afternoon is that the digital revolution provides enormous opportunities for us as social scientists, and we can potentially bring together the very best from the traditions of qualitative and quantitative social science. But I think there's also a risk that we cling on to our well-established comfort blanket of the methods that we know so well, and that we carry on just in the same groove of reading and analysing texts without thinking about the new approaches that are available. So that's one risk. On the other side, we can be distracted from thinking about what the really important substantive problems are as social scientists by continually chasing after the promise of the perfect algorithm for automated text analysis. So it's really important that we embrace new methods, but that we hold on to the tenets of sound social inquiry. And so to begin with, I want to just explore what I mean in this lecture by big data. How am I using the term big data? And apparently the first use of the term big data can be traced to the mid-1990s, when it was used by John Massey, who was a chief scientist at Silicon Graphics. And he used it to refer to analysis and handling of massive data sets. So that was all the way back in the mid-1990s, but it was actually some time before the term became commonplace. So a quick analysis using Google Trends will show that as a search term, interest in the topic began to register in about 2010 and started to grow sharply from 2011 onwards, with a levelling off since around 2014. And although there's no single agreed definition of big data, people often quote Laney and his 3 V's. These are often seen as a helpful starting point. So we talk about the volume or the number of data points, variety, the range of data formats, and velocity, the speed with which data is generated and made available. And on this slide as well, you can see a 4th V, veracity, the idea that we have more uncertainty about the data. And to get a sense of what we mean by the volume of big data, it's worth noting figures from IBM suggesting that each day 2.5 quintillion bytes of data are created. So that I keep hearing this statistic that over 90% of data in the world today has been created in the last 2 years alone. I'm sure in another couple of years we're going to have to revise that, of course, if you think about it logically. And of course, part of the reason for the huge growth in the volumes of data produced are the rise in digital technology, the proliferation of digital gadgets. So Deloitte has estimated that around 32 million phones are purchased each year in the UK, and that 76% of the adult population of the UK now owns a smartphone. So given that this is a festival, I'd like everybody to stand up. So this is just a little bit Graham Norton, not too much. Okay, so stay standing if you have a smartphone. Wow, okay, so more than 76% of the adult population in this room have a smartphone. Okay, and now stay standing if you bought your phone in the last year or it was purchased for you in the last year. Okay, so I know this is a sort of rather unconventional data collection method. Thank you very much, everybody. You can sit down now. But I think that demonstrates not only, the ubiquity of smartphones, particularly amongst educated people who come to methods festivals, but also, the recency, the rapidity with which people buy new devices. And I'm interested as well in the idea that more recently big data has been extended to be thought of as found data, in contrast to more traditional data from censuses and surveys that have been made or collected specifically for research purposes. So people like Tim Harford and Roxanne Connolly and colleagues wrote a paper talking about the fact that we can also think about big data as found data. So administrative data, for example, could be seen as an example of big data. But in this lecture, what I'm going to particularly focus on are textual data and the opportunities that arise from algorithms and machine learning to analyse corpora of texts in totally new ways. Before moving on to that, I'll just give you a brief overview of ESRC's history of supporting data infrastructure for social science research, and particularly focusing on what we've been doing in the last couple of years to support the analysis of big data. But I hope you'll be able to see in the next few minutes just what a challenge we've got as funders, because things are moving so rapidly, and trying to work out how we best supply infrastructure for big data is key. So we go back to the 1960s. The vision to store UK research data securely and make it available for future researchers began 5 decades ago. There was a real concern that poor communication between researchers meant that costly survey work was being duplicated. And in response, it was in 1967 that the data bank at the University of Essex was established. And as we'll see, over the decades, the archive funded by ESRC has continually adapted as the scope, volume and demands of social science data have changed. So there's a nice picture here of Howard Newby looking very young, with the Queen also looking relatively young. The archive extended its function by the mid-1970s and was no longer a simple repository for one-off academic surveys. It took on a role of acquiring, cleaning and cataloguing large government data sets, so things like the Government Household Panel Survey and Family Expenditure Survey. So I've just jotted down some key dates here in the history of the archive, and you can see it moving from a data bank, and that slide that I whizzed past, but with lots of sheets of paper, sort of the survey data of old being stored safely, and then moving on to the idea of machine-readable data, so that the appetite for curation and dissemination of machine-readable data of all kinds really took off by the 1980s with the growth of computing capacity. So in the 1980s, it wasn't just the University of Essex. There were 6 university computing centres that were enlisted to collaborate with the archive to service a real burgeoning demand for data. And it was interesting, actually, looking back, that a House of Lords debate back in November 1984, described the data archive as the Rutherford laboratory of the social sciences. And we can see then the history moving on to not just being about quantitative social science, but in the early 1990s, the Specialist History Data Service was set up. And in 96, we had this renaming of the data archive, and then 2001, a merger between the Quali Data Archive and the old data archive, so that we have the UK data archive today, bridging both qualitative and quantitative data. So today the UK Data Archive directs and manages the UK Data Service and makes available over 7,000 data collections. So we've got survey data sets and census data sitting alongside a wealth of qualitative corpora, transcripts and images, as well now as audio and video recordings. And what I want to emphasise in this lecture is that new forms of data are increasingly transcending this quantitative-qualitative distinction. So it seems really appropriate in the UK that we have a central data archive that curates both extensive qualitative and quantitative sources. And one of my messages is that we don't need to just keep thinking about new social media and new ways of collecting data. We can also go back to data that's been archived for many years to think about how we might use new approaches with old types of data. So then moving on, the new millennium saw a really significant reinvestment in the UK's internationally renowned longitudinal research that Patrick was referring to just now, and there was a renewed commitment to make data freely and widely available. So the ESRC chief executive back in the mid-2000s, Professor Ian Diamond, remarked that in order to fully answer many critical social scientific questions, we will in future need an integrated and coordinated approach that links social science data with administrative and ecological data. And to take this forward, we're working with other funders to commence the development of a national data strategy. So we then see in the 2000s this move to a much more strategic approach to data. And what's interesting is that the argument was successfully won by people like Ian Diamond, but also Peter Elias, who had been appointed as the data czar for ESRC, that social scientists needed investment in infrastructure research in the same way that the physical scientists did. So I quite like the reference back to that House of Lords debate back in 1984, saying it's like the Rutherford laboratory, that we can now see the UK Data Archive and many of our different investments as being like the infrastructure that physical scientists need. So at that point we realised that the large facilities capital fund that had only really been available to that date to the natural sciences could be used by the social sciences. So following this emphasis on data as infrastructure, the Administrative Data Task Force was formed in 2011, bringing together a range of different stakeholders, including government departments and academic experts. And it was as a result of the ADT report that the proposal came through to set up the UK Administrative Data Research Network, and that was set up in 2013. So ADRN providing state-of-the-art facilities, a couple of pictures of ADRN based just outside Edinburgh. There's one ADRN centre for each of the countries of the UK, and I'm sure many of you will already have visited the stand outside for ADRN, but I do suggest if you haven't already done so, go and find out what they're doing and what they're providing. So the ADRN was just the first phase of the ESRC's big data network. Phase 2 of the network saw ESRC invest just over 23 million in 3 data research centres, all launched in 2014 to enable safe access and research using business and local government data. So we've got the Urban Big Data Centre based up in Glasgow, but with links to many other institutions. The Consumer Data Research Centre, which is joint between Leeds and UCL, and the Business and Local Government Data Research Centre at Essex. We're still very much in the middle of commissioning and sorting out the third phase of the Big Data Network. It's not yet complete, and it focuses primarily on data from the third sector and new forms of data. We're really interested in making a focus on real-time data analytics, so moving to that third V of big data, the velocity of big data. And we want to be able to invest in research that's testing innovative visualization tools and new interdisciplinary methods. So really exploring the potential for new forms of data to be combined, shared, and used in conjunction with existing social science data. But at the moment, we're going through the painful process with our sponsor department, BIS, of finalising the business case. And as I've said, what's a challenge here is things are moving so quickly. I think it's important to acknowledge that despite the careful work done by the Administrative Data Task Force before we commissioned the Administrative Data Research Network, those running administrative data research centres are still finding it a real challenge to work with data owners and make sure that government departments are agreeing to share their operational data for research purposes. I've also spoken to people at the Consumer Data Research Centre, and although they've got a fantastic website, lovely visualisations of some data mapped across the whole of the UK, they're also finding it challenging to get access to data from commercial companies. And I'll come back to this point at the end, but in a way there's huge potential excitement here, but there's also that feeling that some forms of data are still a little bit beyond the grasp of researchers. And we need to think as a body of social scientists how to solve that puzzle. Part of the ambition for the Big Data Network then has been to facilitate access to a much greater range and variety of data than ever before, and to ensure that researchers can use it to address pressing social science challenges. So the network has been designed to offer the potential for using and linking different scales and types of data that very much cut across disciplinary boundaries in a way that's secure and consistent with research ethics. So importantly, the drive for big data investment from ESRC has been about recognising that although these new forms of data are being used by researchers, the process has been somewhat painful, slow and expensive, and to some extent limited to a small group of researchers with the will, contacts and capability to do this new innovative work. So the aim of the Big Data Network is to fix that by creating services which ease much of the weight of work on individual academics. The aims are to build capacity, develop new infrastructure and tools, and develop partnerships and interdisciplinary collaborations. But of course, the ESRC is not the only research council with an interest in providing data infrastructure and developing new methods of analysis. In November last year, with substantial funding from the Engineering and Physical Sciences Research Council, the Alan Turing Institute was launched and is establishing its headquarters as part of the British Library. It brings together leaders in advanced mathematics, computer science and the social sciences, and draws on 5 founding universities, Oxford, Cambridge, Warwick, UCL and Edinburgh, as well as other strategic partners and funders. And the aim is to undertake data science research at the intersection of computer science, mathematics, statistics and systems engineering. And this is a picture of their website and the web link there. So do, if you haven't come across the work of the Alan Turing Institute, do get involved. This is a great time to engage with the Alan Turing Institute as it embarks on a whole programme of work. And as ESRC, we've been trying to facilitate an active approach to engagement between social scientists and the Alan Turing Institute. But I'm aware that we need this sort of two-way process So we need to build and broaden the social science interest and capacity to use algorithms and machine learning in research. And I think it's only then that we'll be able to engage as social scientists with developing new techniques and methodologies in partnerships with other disciplines. So as social science research funders, it's clearly our responsibility to take a leading role in supporting infrastructure for research, taking account of these new developments in data science, and to facilitate dialogue with other funders and other disciplines. But I'd argue for all of us as social scientists, we have a duty to engage fully with these new methods and to ensure we're as well informed as possible about their potential. So I'm very pleased to see on the programme for this Methods Festival a number of different sessions on big data or new forms of data, and I see there's a What Is session on big data on Thursday and sessions tomorrow morning on administrative data. But I would hope that in a couple of years' time at the next Methods Festival there'd be even more prevalence on algorithms, interdisciplinary work, new forms of analysis at the Methods Festivals. It's a really big field and I'm not going to be able to do it justice in this lecture, but I'm going to move on to talk a bit more about different types of data and different types of analysis. And as I said at the beginning, I really want to inspire you to find out more about it. So before discussing different types of analysis that are now possible, and thinking about the algorithms that can detect regularities and patterns in even most complex textual data, I think it's important to focus on the very many types of data that are amenable to analysis with the aid of computers. And one of the dangers that I've noticed in a number of presentations I've been in over the last couple of years, that often sessions say they're about big data and they then turn out to be about Twitter. Yes? Now, you know, I am at Jane Elliott 66, so, you know, I am interested in Twitter, but I think although it's an intriguing new resource for social scientists, it's by no means the only type of data that could be considered as big data. So in what follows, I'm going to try and avoid using too many examples from Twitter. I'm going to focus mainly on textual data, and I won't really be able to do justice to visual data, but I'll use a couple of examples. And I'm aware there's a huge variety of empirical material and approaches, and I'm hoping that those will be covered in some of the other sessions during the festival. So arguably, the digital revolution has really increased the amount of text that's being produced by members of the public and that's available for analysis. So if we think about sort of naturally occurring textual data now, we can include things like blogs and tweets, contributions to discussion fora, comments in response to newspaper articles. So these are all things that are examples of written material now readily available for analysis. And I think this speaks to a point made by Savage and Burrows back in their 2007 paper on the coming crisis of empirical sociology, and of course that debate has gone on since 2007, that one of the challenges for social scientists is that our expertise is no longer essential for the collection of data. And I was in a session before lunch with Mark Elliott and Patrick Sturgis arguing about, you know, should we see it as the end of the survey method, the fact that we've now got so much digital data that's being produced. So the digital revolution, ready access to the internet and the availability of cheap computers and smartphones has led to a huge growth and ubiquity of data and empirical material available for analysis. And one way of thinking about this, I think, is in two dimensions. So for the first time, we can start thinking about text that was produced completely independent of the research process. So that's the things on the left-hand side versus text that's been specifically elicited for research purposes. And then we can make another dimensional distinction, text derived by transcribing, free speech, and text that was originally written. So what I'm arguing is that we can see a huge increase in the data available in this top left-hand corner. Textual data produced independent of any research project, already in digital form. So just briefly, using Twitter as an example, apparently there are 2 billion registered Twitter accounts, 310 million people are regular users of Twitter, and over 500 million tweets are sent each day. But you can see that tweets are just one of the examples that I've highlighted in red. And as I'll come back to later, much of the data in this top left-hand corner shares some of the characteristics of qualitative data, because it's got rich text that needs interpretive approaches for analysis. But each segment of text is also likely to have a number of structured variables that could be associated with it. And while you could argue that's always been the case, that if you conducted 25 open-ended interviews and you transcribed them, that each one of those 25 interviews would also have a series of fairly structured variables associated with it, like the age of the person, their gender, where they were located when the interview took place. You can see that perhaps going back a few decades, you would only ever expect to have maybe 25 interviews or a few examples of text, whereas now we've got such a huge amount of text available, we have these data sets that have both the sort of qualitative and the quantitative aspects to them. So in order now to exemplify in a bit more detail how machine learning and the concept of big data could transform the way that we conduct and think about analysis, I'd like to go back to share with you an example of some analysis I carried out a few years ago using some very traditional methods of coding textual data, and then move on to think about new ways that we might approach that data now. So as Patrick was briefly explaining, before I took the role of Chief Executive at ESRC, I was Principal Investigator of the 1958 British Birth Cohort Study. And for those of you who aren't aware of the study, it's a fascinating longitudinal study focused on all of the people who were born in 1 week of March of 1958. So it started off with 17,000 babies, and it's followed them through their childhoods into adulthood and middle age, and the next data collection is planned for around their 60th birthday in a couple of years' time. Now, as part of that very detailed longitudinal study, when the cohort members were just 11 years old, so in their final year of primary school, and this was 1969, just as we were landing on the moon, they were asked to write an essay about how they imagined their life to be at the age of 25. And you can see on this slide the exact wording. They were asked, it sounded a little bit like an exam question at the time. Imagine you're now 25 years old, write about the life you're leading, your interests, your home life and your work at the age of 25. You have 30 minutes to do this. Yes, quite a sort of daunting task for an 11-year-old. The reason, though, that I'm reaching into the past to use this example is to really get across the point that we could be using new methods with data that's been collected many years ago and that has fascinating potential, but also to think about the fact we probably are already on the point of having essays and textual material collected at Key Stage 2 from children across the country, thinking about the potential there for analysis. So, as a result of the study, there was a collection of 13,669 essays with a mean length of 204 words. They vary from just a few words to several hundred words in length. And I've given you here an extract of just one essay. We'll come back to it again in a minute. I'm going to give you a chance to read it while I have a mouthful of water so that you get a sense of the type of material that's here. So I hope you can immediately see how these essays could be seen as an early example of big data. A corpus of over 2 million words in total. So perhaps not quite as many words as the Chilcot report. And again, this is one of those data sets that bridges the qualitative-quantitative divide, because associated with each essay is a very extensive longitudinal record of data on each child and on their adult characteristics. Now, unsurprisingly, back in the early 1970s, the data was much too challenging for the research team to analyse in full. And instead, each essay was simply coded into one of 21 categories according to the occupation that the child aspired to. So they really just focused on the question of what do you want to be when you grow up. And the following graph just shows a simple analysis by gender of the 10 most popular occupations. I'm not going to really dwell on this, but just to share it with you for interest. You can see that, as we might expect, very gendered occupational aspirations back in 1969. Many more boys than girls wanting to be skilled manual workers, and this was often sort of the Camberwick Green Trumpton type of, being an electrician or a plumber or a fireman, those type of occupations. And boys also more likely than girls to want to be professionals, but the girls more likely to want to be teachers. Now, given the lack of resources to analyse the essays fully in the 1970s and the lack of technology, the research team at least ensured that each essay was preserved on microfiche. And for many years, they sat in the archive at the Centre for Longitudinal Studies, virtually unknown, but just with people analysing this variable N958, if I remember rightly, if you want to go to the data set. And because of my interest, as Patrick said, in combining qualitative and quantitative material, in 2006 I applied for a small grant from the Nuffield Foundation with my colleague Ginny Morrow, and we set about transcribing and coding a stratified sample of just around 500 of the essays so that the material could be archived at the UK Data Service in Essex. And it's there now, and I think more of the essays have now been digitised as well. And just to give an insight into the old ways of doing the coding and analysis, in order to conduct the coding, we recruited a small team of 3 or 4 research assistants, and Ginny and I read around 60 of the essays, and we inductively devised a simple coding framework to try and capture the key topics that kept recurring in the essays. So we were really trying to just do some descriptive work and to show the broader research community what types of themes there were in these essays and allow people to do further analysis. So this slide is a simple summary of some of the key themes emerging from our reading of the essays, and I've colour-coded them. I've particularly chosen the ones that were more gendered, and you can see the ones coloured in green are the ones that the girls tended to write about more, and the ones coloured in red are the ones that the boys wrote about more. And you can see right at the very bottom that football stands out as a topic very rarely mentioned by girls and much more often mentioned by boys. And although there were some gender differences, I think it's important to say that there were also a lot of similarities in what the children were writing about. And it was really striking how many of the boys were writing about getting married and having children. In fact, there's one lovely essay I remember from an 11-year-old boy who says, "When I'm 25, I will be married and have 2 children. When I was 11, I did not want to be married." Fantastic sophistication. I'd like to meet him and shake his hand. But my point here really is that this type of coding is laborious. And the advances in technology that we have now raise this question as to whether machine learning could be used to replicate and indeed to improve on this type of coding that we were carrying out a decade ago. And it's also important, though, what I've shown here is a very basic content analysis, which we probably would think that a computer could do. It's also important to acknowledge that this is just one approach to understanding the children's essays. So there's an interesting paper by Moore et al. In 2015, a recent article in Big Data and Society, that argues we can distinguish thin reading of text from thick readings. And this is quite a nice way of thinking about different types of analysis. so that we can perhaps contrast content analysis, the sort of very basic analysis I was describing, looking at the different topics emerging, and you can see how you could do word counts almost to find that, distinguishing that from a more poetic analysis. And if I return to the slide of the essay, we could look at this in terms of some of the topics that are there, but we can also look at it, there's a sort of theme here that I see, which is talking about a very routinized day and talking about, we get up at 5 o'clock every day, for example, and we do the milking and then we have our breakfast. Yeah, so this sort of real chronicle of what happens on a daily basis. Now, having read almost all of these 500 essays that we transcribed now, I know that's one of the sort of recurring genre, in a way, is this chronicle of the day. And what fascinates me is the extent to which we're now looking at machine learning that could detect those sorts of patterns. And that's the sort of thing I think we should be looking at more as social scientists, is not assuming that computers can only do very basic word recognition, but can start to look at patterns. So whereas in content analysis the aim is to capture the manifest meaning and primary ideas in a corpus of text, a more hermeneutic analysis attends to those dimensions such as rhetoric and genre. It seeks to uncover the contradictions and complex meanings in a text and would be interested in rhythm and poetics as well as the content. So keeping in mind this idea that there's not just one approach to the analysis of text, I'd like to move now to explore with you just some of the key dimensions of machine learning. And I've come across a number of different definitions of machine learning. In very broad terms, the field can be said to be concerned with how to construct computer programs that automatically improve with experience. So that idea that the computer is learning. And Nick Adams, in a recent article, has argued there's nothing very new about the concept of machine learning. So those who are used to quantitative analysis techniques, such as ordinary least squares regression, logistic regression and cluster analysis, all of those can also be seen as a type of machine learning. But machine learning is often divided into two main types in the literature, and I think this is quite a useful way of thinking about it. So there is both supervised and unsupervised machine learning. And these shouldn't be seen as competing approaches, but just different models with different objectives. So in the case of supervised machine learning, the result is already known. So the example, the rather trite example that's often used is that you can show a computer many different images of dogs and cats. And the task is for the computer to build an algorithm that enables it to distinguish accurately and effectively between the two types of image. And this type of machine learning is known as supervised machine learning because as humans, we're already pretty good at the task. And so we can tell the computer whether it's correct or not. But of course, we can give it an occasional complex case. So, supervised methods then assume a well-defined and very well-understood set of categories before the automated analysis begins. And a couple of good examples of practical application would be distinguishing between real emails and spam emails. We'll all probably be using algorithms which do that for us. And there was a great example today in The Guardian of some work using more visual techniques, and it's a collaboration between Google and its DeepMind arm of Google and Moorfields Eye Hospital, and they're using images of retinas and using machine learning algorithms to try and detect degeneration and eye disease due to degeneration. So a very practical approach. So that's supervised methods. In the case of unsupervised machine learning, we're interested in whether the computer can distinguish different classes of objects or cluster different types of text without a predetermined human solution. So we could think of this as a type of abductive process through which the computer algorithm uses the information available to propose to us possible solutions. And for social scientists, it's this class of unsupervised machine learning models that have the greatest utility, particularly when applied to large corpora of text. And this is something that DiMaggio has argued, again, very recent paper, 2015. Grimmer and Stewart have argued that unsupervised models are valuable because they can identify organisations of text that are theoretically useful but previously unknown. And I think this is perhaps the holy grail of using algorithms to enhance our human capability in the careful reading and analysis of text. There's something a bit magical about the idea that we might be able to feed a large corpora of things like those essays into a machine, an algorithm, and get it to tell us what the different classifications are. So if we return to that example of children's essays, we could use supervised machine learning to distinguish boys' essays from girls' essays. We already know whether they're written by boys or girls, and this may not immediately appear to answer a particularly interesting social science question, because we know whether it's written by a boy or a girl. But if after a brief training period the computer misclassified some of the essays, you can see it might be of interest to analyse the misclassified essays, so maybe, you know, the girls that were trying to be a bit more dog, in detail to understand the ways in which some children were writing essays that were less gendered than the norm. And we can think about people like Janet Gieler's work about vanguards in cohorts and how there are particular individuals who really are at the forefront and changing the way that they do things socially. So this might be a fascinating way of saying, are there some essays that reveal children who are writing in a different way, have a different type of identity at 11? In contrast, you can see that application of unsupervised methods to this corpus of children's writing holds the promise of uncovering previously unrecognised groupings of essays that corresponds to typology mapping onto an interesting set of theoretical constructs. And in recent years, more complex algorithms have been devised to examine underlying structures of text and to provide models for the relationships between the topics and the themes that appear in the texts. So it's a combination of the more hermeneutic analysis and the content analysis that I was showing earlier. So there's these useful 4 principles, though, of quantitative text analysis. This paper's slightly old now, from 2013, but I think it's quite useful. We need to be enthusiastic about these new methods, but we have to recognise that all quantitative models of language will in some ways be wrong, in that there'll be an oversimplification, and we have to think about what's useful about them. And we need to think about these quantitative methods for text as amplifying and augmenting humans. And a key point is we always have to go back to the solution and see if we can validate it. Can we make sense of it? Is it a useful solution in terms of our theoretical constructs? Indeed, does it help us to develop more interesting theoretical constructs about what's going on in the data? So there's now clearly a vast array of texts that are available to us for this type of analysis, and there's not just one approach. There are now a myriad of algorithms that fall under this broad umbrella of automated text analysis. However, and as I'll come back to at the end, as Grimmer and Stewart caution, validation is key, and any application of methods needs a great deal of thought and careful reasoning. So I'm going to move on now to briefly cover a further opportunity that has arisen from the digital revolution, and that's this idea, this possibility of using crowdsourcing to conduct analysis of large bodies of text. And this comes in a way to Grimmer and Stewart's idea about quantitative methods amplifying and augmenting humans. We're then in a way using the crowd to augment our research team. So in the context of coding text, the principle behind crowdsourcing is that even though each individual coder may not be totally reliable, if you have a number of people coding each fragment of text, in aggregate, your results will be unbiased and robust. Indeed, it's argued that crowdsourcing can help to produce a data set for analysis that's reproducible. In other words, using the same coding instructions, any future researcher could feasibly replicate or extend the process of dataset construction. And a useful example is provided in a methodological paper in the American Political Science Review by Benoit et al., just published a couple of months ago. And the researchers used a crowdsourcing platform called Crowdflower to facilitate coding of recent manifestos from political parties in the UK. And they focus on two main dimensions: economic policy and social policy. This is an extract from their paper. And the researchers used Crowdflower to instruct coders to classify each sentence in the manifesto according to whether it was about economic policy, social policy, or neither. And then once a sentence was classified, readers were asked to rate it on a 5-point scale. So for economic policy, whether it's from very right to very left, whereas sentences classified as social policy rated on a 5-point scale from liberal to conservative. And what's interesting about the methodological paper is that identical instructions were given using the crowdsourcing platform and to a small group of expert political scientists. And the results obtained demonstrated that the coding conducted using crowdsourcing correlated incredibly highly, so stronger than 0.9, with coding carried out by experts. So again, this is an extract from the paper, and you can see each of the sort of circles there is one of the manifestos. The blues are the Conservatives' manifestos, the red are the Labour manifestos, and you can probably just about see the dates in them. So you've got things like 2010, 2005 there. And the authors therefore argue that this provides a very effective, agile and cost-efficient way of conducting a basic content analysis. So I think that's a really neat way of seeing how we can use computers, digital revolution to augment human analysis. And what I really like about the paper is that the authors give a very practical sense of how they conducted the research. And they even describe how the coding of 22,000 sentences cost just $350 and took just 5 hours. So it's remarkable. By giving just a few cents per coding task of 10 sentences, they were able to accomplish so much. But they're also really honest about the fact that the process of setting up the project, learning the new technology, fine-tuning the instructions was incredibly resource intensive. So none of us are going to get our next paper published on $350 and 5 hours, I'm afraid. But they make the point that once the method has been established, the benefit is that it's robust and extensible. And of course, this type of crowdsourcing could be used to produce data sets that could be used as training data sets for supervised machine learning. And then you could go on to train the computer to do the unsupervised type. So in summary, this is another way in which we can use digital technology to augment rather than replace analysis carried out by humans. So before making some concluding comments, I'd like to consider for a moment the extent to which this proliferation of new material for empirical analysis and the development of new methods is indeed blurring the boundaries between qualitative and quantitative approaches. And I think there are perhaps two main ways in which the digital revolution could be seen as bridging the traditional divide between qualitative and quantitative researchers. So first, as I've discussed very briefly earlier, the new corpora of text that are now amenable to analysis often combine characteristics of both qualitative and quantitative data. The rich textual material we now have available has been traditionally perhaps seen as the preserve of more qualitative researchers, and yet we can now see this increasingly combined with structured data at scale. So if we use tweets as an example for a minute, we've got 140 characters of text, but they can also be located in time and place. We also have simple metrics attached, such as number of retweets, replies, and favourites. And I already discussed the way in which those children's essays can be seen as combining characteristics of qualitative and quantitative. So at the level of empirical data, it's perhaps more difficult now to distinguish qualitative and quantitative data sets. And then secondly, the types of methods that are being developed to analyse these new types of data need to draw on the expertise of both qualitative and quantitative social scientists. So Gary King wrote in 2014 that instead of quantitative researchers trying to build fully automated methods and qualitative researchers trying to make do with traditional human-only methods, now both are heading towards using or developing computer-assisted methods that empower both groups. And he makes the point that this development has the potential to end the divide, to get us working together, to solve common problems, and to greatly strengthen the research output of social science as a whole. So to come to some conclusions, I think it's undeniable that we're living at a time of great opportunity for social science. The digital revolution has led to the generation of a huge amount of new empirical material that can be interrogated to help us understand more about individuals, the social networks and social institutions that they contribute to. More than ever before, we have access to quantities of rich textual material that have been produced by individuals as part of their daily lives. Whereas in the past, when data was collected specifically for research purposes, it was seen as precious, a scarce resource that back in the 1960s needed to be lodged in a data bank. We now have the fire hose of Twitter and repeated reminders of the exabytes of information that we generate on a daily basis. However, as I mentioned earlier, although there is this ubiquity of data, there are still some data sets that can be seen as more intrinsically valuable than others, and access to those data sets, even in anonymised form and in safe settings, can be a real challenge. There's considerable frustration still among academic researchers that although on the one hand there's a plenitude of data, often the data resources they most need are still tantalisingly just beyond their grasp. So this leads me to finish with three main challenges for social scientists. First, there's the methodological challenge. How we can develop the very best tools to help us interrogate, analyse and understand the vast quantities and varieties of data that now exist. In particular, how can we ensure that the methods we use for analysing textual material fully exploit the potential of machine learning techniques? Although there's undeniably a small vanguard of individuals and research centres working productively with colleagues from computer science and mathematics to develop new techniques, this is still very much a niche area of working. Many academic researchers are continuing to use the methods and techniques that they are familiar and comfortable with. So that's the first challenge, the methodological one. Secondly, there's a challenge of developing insightful research questions. And this can sometimes, I think, be seen as in tension with the first challenge. In other words, there's a danger that social scientists at the cutting edge of developing methodological techniques can get distracted by the fascinating puzzles of how to interrogate a new corpus of data rather than focusing thought and energy on the substantive evidence that can be gleaned from the empirical material. So at ESRC, we're particularly interested in how we can help facilitate co-creation of research questions, bringing together practitioners, policymakers and academic researchers so that they can construct questions that are interesting, useful and tractable. There's an iteration here between the interesting and the possible, arguably as new technologies such as machine learning make it possible to ask different types of question from text. This should fuel our imaginations to think of new sets of substantive research questions. Thirdly and finally, we do of course need to address ethical questions that are raised by new forms of data and new approaches to analysis. And I'm aware there's a session on ethics later this afternoon. I decided it was too ambitious to try and cover ethical issues within this lecture, but the new ESRC framework on data ethics includes sections on internet-mediated research and other elements relevant to the use of big data. In addition, we heard a few months ago that the government is establishing a data science ethics council within the Alan Turing Institute. So arguably, if we can satisfactorily address these three main challenges of methodologies, really good research questions and really good ethical research, we'll then be more successful in gaining the trust of data owners and of the individuals and public who generate big data. It's once these three challenges are met that it's more likely that we will have access to the valuable data that's currently just out of reach. It seems to me that there is the potential for a paradigm shift in the practice of social science, and we need to be confident about what we bring to the table as social scientists. But we also need to be ready to learn from other disciplines to develop and renew our methodological toolkit.